Now, the next topic we have to cover in this chapter is the fundamental theorem of arithmetic. This is again a theorem which says every composite number can be expressed or factorized as a product of prime numbers or primes. Primes are also known as prime numbers. And this factorization is unique apart from the order in which the factors occur. So what does this mean is that any composite number, say 15, 10, 18, 19, anything, 19 is not a composite number, that is a prime number, any composite number can be expressed in the form of product of its primes. Like, for example, we have 15 which can be expressed as prime number 3 into prime number 5. Correct? Now, they say that this factorization is unique. This factorization is unique apart from the order in which the factors occur. So, what does the last line mean? The last line means that this order, like 3 and 5, this can vary. Like 15 can be written as 3 and 5, 3 into 5, or this 15 can also be written as 5 into 3. Correct? So, this order differs, but the factors will always remain the same. Now, I'll give you another example. Like, take an example of 20. Now, this 20 over here can be written as 2 into 5. Correct? This can also be written as 2 into 5 into 2 or 5 into 2 into 2. Correct? These are all 20. But if you see over here, 2 square into 5, this is how this can be factorized. That is it. If we say that the factors should occur in ascending order, say in ascending order, so this case and this case stands. So it is, the factors are unique in that case. There is no order also that can differ. So factors are unique. So the order can differ, but the factors are always unique. Any number, any composite number can be expressed in its primes, and these factors are always unique. This is what the fundamental theorem of arithmetic says. All the arithmetic operations are based on this fundamental theorem. So very basic, very important. Now we will use this fundamental theorem, or we will use these factors, the prime factors of composite numbers, to find the LCM and HCF of a few numbers. Now I'll give you an example. The question over here says, find the LCM and the HCF of 96 and 404. Now in junior classes, we used to find the LCM of a number by factorization method. We used to draw this table like this, and we used to write 96 over here and 404 over here like this, right? And we used to divide this by 2, and then whatever comes we used to write over here, and then it would be like, this would be 48 and this would be 202, and this would again go by 2, and this would be 24, this would be 101, and so on, right? And then we used to multiply all these numbers, and that used to be the LCM, correct? Now this method is again similar, but we don't have to write it in this way, correct? So how do we do that? So first of all, what do we do is, we express 96 and 404 in its primes, right? So 96 over here can be written as 2 raised to power 5 into 3. Now I have already done this. You can check it, you can do it yourself. How do we start doing this is, we first of all see how, if the number is divisible by 2. This number is divisible by 2. The next number is 48, it is still divisible by 2. So next number is 24, it is still divisible by 2. So we keep writing 2, 2, 2, 2, 2, and then in the end 3 remains, so we write 3. So this is 2 raised to power 5 into 3, that is the expression of 96. So how is 404 expressed? 404 is 2 raised to power 2 into 101. 101 is also a prime number. So now we have expressed 404 and 96 in its primes, correct? Now how do we find the LCM and the HCF? The LCM is, so first of all I'll tell you how to find the HCF. So to find the HCF is the only common part in these factors is the HCF. So tell me what is the common part in this. If you take this and this, what is the common part that will come out? It is 2 raised to power 2, right? Or I can say 4. So the HCF is the 2 raised to power 2 or 4. Did you understand this? 2 raised to power 5 is here and 2 raised to power 2 is here. So the common part is the LCM. Correct? And sorry, the HCF is the common part. And how do we find the LCM? LCM is write down everything that is there in this and then subtract the, we have to write like everything in multiplication, like 2 into 5 into 3 into 2 raised to power 2 into 101. Okay, and then we have to see if there is something common, we take that, we bring that out. If there is something common in this and this, we bring that out and write the only part that is remaining. I should not have written this over here. So what do we do is 2 into 2 is common, that does not come in this, rest everything comes. So it is like 2 raised to power 5. Okay, so when we write 2 raised to power 5, 2 raised to power 2 is already included in that. The next expression is 3. The next 2 raised to power has already been included and the next one left is 101. Did you understand this? I'll tell you again. First of all, to find out the HCF, what do we do is, we see what is common in these factors and these factors, and that is the HCF. Okay. So now let's come to the LCM. Finding HCF is very easy from this. Now let's come to the HCF. We start from the upper one. We write over here 2 raised to power 5 first of all. Correct. Next we go on to 3. Was 3 included in these 2 into 5? No. So we write 3. Next we come on to 2 raised to power 2. This 2 raised to power 2 is already included in this 2 raised to power 5. So we don't write 2 raised to power 2. Next we come on to 101. So that is another one. So we write 101 also. So this is the LCM and this is the HCF. So the LCM from here comes out to be equal to, I have already done the calculations in the rough, you have to do the calculations. This is 9696. 9696 is the LCM for 96 and 404. So next what do we do from here is that there is another property that LCM and HCF satisfy, that is the product of numbers of the two numbers is equal to, the product of two numbers is equal to the product of LCM and HCF. The product of these two numbers, that means 96 into 404, 96 into 404 will be equal to 9696 into 4. The product of LCM and the HCF. You recheck this at home, this result will come out to be equal. So what does that mean is that using these this arithmetic, fundamental theorem of arithmetic, what do we have to do is we just have to find the HCF. Once we found out the HCF, that is very easy. There is no you cannot make a mistake while finding the HCF actually, but you can make a lot of mistakes while finding the LCM. So find the HCF and then what do we do is we multiply both these numbers and divide it with the HCF, and that will give us the LCM. So another way to find out the LCM is, so another way to find the LCM is, so this way you have to start after this step. After this step, so you don't have to do this. So how do you find the LCM is? LCM is the product of both the numbers, that is 96 into 404 divided by the HCF, that is 4. So this is another way to find out the LCM. So you can either use this way or you can use this way. But I would suggest you to use this way because this is easier and you have lesser probability of making a mistake in this way. But this way is a little more complex and you have to apply logic over here in this, like to take what to take common and what not to take common. So I would suggest you to use this way instead of using the other way. But yes, this is the basic way to find the LCM. We used to do this in the junior classes. This is just donated in some other way, and this is a new way to find the LCM by finding out the HCF first and then finding out the LCM from this.